Okay, so in 9.1 we looked at correlation analysis, which is it's finding a value that measures the strength and the direction of a linear relationship. Once we know that there is a significant linear relationship, we might want to go and look at linear regression analysis, which will find us a model of that linear relationship, and we can then use that model to predict values. So, first, a regression line is the line of, it's also known as the line of best fit. It's the line that falls in the data values and models the data value the best. It can also then be used to predict values of y for a given value of x. Recall, y is the response variable and x is known as our predictor variable. The residuals are the difference between the observed y values and the predicted y values. Okay, so these are our predicted y values on the regression line, but these are the actual y values, and this is the difference between them. That's the difference between those two, the difference between those, the difference between those. What we're looking for is the line that makes these differences the minimum or the smallest. Okay, so what we're going to look for is the sum of the squares of the residuals to be a minimum. That will be the line that best fits that set of data. The equation for a regression line is the same equation you're used to, y equals mx plus b, except now we're going to call y hat the predicted value, and m is the slope and b is the y-intercept. This is back from high school algebra 1. Slope and the y-intercept. And that's the predicted y value for a given x value. The y, the little symbol over the y, we call that y hat. Now y hat is determined by the slope and the y-intercept. We can find the slope using this formula, but if you notice, these values here are the same values we had in our table that we used to find the correlation coefficient. So as long as we keep those values, we can continue using them. And then b is equal to y bar, which is the mean of the y values, and x bar is the mean of the x values. You know how to find the mean of any set of values. Add up all the y's and divide by the number of y's. Add up all the x's and divide by the number of x's. So this is the sum of the y's divided by n minus m, so you have to find the slope first. And x bar is the sum of the x's divided by n. Then another property of the regression line is the regression line always passes through the point x bar, y bar. So let's continue with the example we had in 9.1, where we set up the table to find the correlation coefficient. Recall this table, right? And now we're just going to use those values. N was 10, the sum of the x times the y. The sum of the x's, the sum of the y's, n times the sum of the x squareds minus the sum of the x's in its quantity squared. Plug those values in, and we get m is 196.151977. B is y hat minus m times x hat, which is the sum of the y's divided by 10 minus the slope times the sum of the x's divided by 10, and we get that y hat is equal to 196.152x plus 102.289. This is the equation of the regression line. This is the equation of the line that best fits that set of data. If we wanted to sketch that line, you plot the y-intercept and then use the slope to come up with another point. You can also use the point x bar, y bar, and the y-intercept to, once you have 2 points on a line, you can then draw the line. And we can see this looks like a fairly strong positive linear relationship, which is what we realized in 9.1 when we found the correlation coefficient for this set of data. Now let's use our regression equation right here to predict the expected carbon dioxide emission from the following GDPs. So if a country had a GDP of $1.2 trillion, we would plug in for X 1.2, For a country that had a 2.0 GDP, we would plug in 2.0 here and then 2.5 there and get that we expect the emissions to be around 337.671 for $2.0 trillion GDP. We predict that the CO2 emissions are about 494.593 million metric tons. And for 2.5, we have a prediction also. So the prediction values are only meaningful, though, for values in or close to the range of the original data set. In our original data set, the X values ranged from 0.9 to 4.9. So this would not be appropriate to use this regression line to predict for values outside of those two values. It would not be appropriate then to predict for a country that had a GDP of only 0.2 trillion or a country that had a GDP of 14.5 trillion. This regression equation here is only good for values ranging from 0.9 to 4.9. That's the end of 9.2. You can now go to the homework set on the course compass and do the homework for section 9.2.